We're currently on Varsto's website and to see what kind of variable information can be abstracted from the p-files. We talk about signature, right? For this specific sample, its signature cannot be verified. Okay, there are two different scenarios. First, it does not include any signature. Or second, it includes some signature inside the PE file. However, those signatures cannot pass the verification function. We can see that there are 3 signers in this PE file. So we can click it and see, okay, the signer's name is called LEDIOOO. You need to have a private key, right? Some issuer should keep your public key after you have your private key. So there are some date information, usage, something algorithm, and something like that. However, even if this P file contains 3 different signatures, however, those signatures cannot be verified. For example, this signature is expired. As we can see, this signature only valid from 2018 to 2018 October. So this signature cannot be verified. Or, for example, right here, this signature is not expired, right? It's valid until 2028, and its status is valid, which means it is a valid signature. However, you can imagine that a signature is a chain, okay? So although 2 of the signature is valid, however, 1 of them is not valid, and then this signature chain is broke, so we cannot verify. 中文的意思是说，签章这件事情实际上是一条链。所以我们这边有3个签章嘛，可是你可以看到下面2个 status 是 valid， 也就是说下面2个签名是没有问题的，可是第一个签名是有问题，所以这个链就断掉了，就破了。在我们的认知里面，如果签名没有全部是 valid 的情况之下，这个签章就是错的，就是失效的，所以我们就说这个没有办法过整个认证 verification. There are some PE file information. PE stands for portable executable. Okay, there are some information can be extracted from PE headers. For example, target machine. Okay, we have talked about machine. There's a specific field in the PE file. It is a Intel 386 architecture and is compiled at 2018. Its entry point, which means the offset of your code, is 6224 byte. It has 4 sections. As we mentioned before, there can be a lot of different sections. Each section contains different code or resources, for example, image or strings. When you compile your code into a P file, your compiler will put different resources, strings, code, or a global variable, something like in different sections. Right here, we have 4 sections. There are 4 different names: .text, .rdata, .data, .rsc. .text text means the code you write. Those for loops, those if else conditions, your statement, your assignment, your functions, all those things will be compiled into assembly and put into this section called text. So basically the size is 65536 byte. And for this section, text section, to MD5 hash function, and the output is a unique value 65 blah blah blah. And there are 3 other sections. Usually data or our data are for example your strings, your variables. Our resources, usually those sections includes some image or some strings. Remember, there is a value right here called entropy. We will talk about this specific column by using our code. And we can see that this PE file imports different DLL file. DLL stands for Dynamic Load Library, which means those functions, those libraries are provided by Windows. So you don't have to implement those code. You simply just include those libraries and invoke those libraries. A malware sample, it uses several functions. For example, get this arrow, hit 3, locate real, allocation, LC map string, some function which maybe you don't know, but those hackers, they use this library, those functions provided by kernel32.dll file. And of course, there are some other functions from other libraries. So you have to think about one thing. As a normal programmer, when you deploy your benign software, what kind of Windows function you will use? Are they totally different from hackers' program? You have to think about this question. If you believe the function you use and the functions used by the attacker, they are different, and then you can use these functions as your feature to create your classifier. 好，从我再讲一遍哈。所以我们走到这边的时候，你要思考一个问题，就是说我们现在如果要辨好人写的字跟坏人程式，那你可以想一想，好人就是你啊，你写的程式，你使用的这些 functions 跟 library 会跟坏人使用的 functions 跟 libraries 会不一样吗？如果你觉得你用的 function 跟坏人用的 function 会不一样的话，那么你应该就把这件事情好好的记下来，把它当做一个 feature 来用，然后呢，在你的 classifier 里面去考虑这个，对吗？那去考虑这个 feature 的时候，你的 classifier 就可以，你的 model 可能就会根据这个项目我们说你有很多 feature， 你可以有 S1、S2、SM 嘛，对不对？那你可以有某个 feature， 就是说，哎呀，你的程式有没有使用到 isChild 的这个 function？ 如果你觉得大部分的坏人有用，可是你没有用，一般的好人都没有用，那这个 feature 就很有价值，你就应该当做其中一个 X， 然后你去 build 你的 classifier 的时候，你就可以用这个维度好人坏人分开来。So you have to consider those functions used by malicious software. It's indeed they are so unique, so normal users will not use such kind of functions. If you do think so, then you should put this information in your classifier. So further, there are some other information right here. I think that is enough for us. Okay, so next, relation. If those malicious software, they would like to contact remote server, for example, HTTP server, HTTPS server, at least they have to include those URL, 就是 website URL in their pefile, right? 就是说你要让这个坏的程式去连到remote 的 server， 比如说 HTTP server， 你起码要把那 HTTP server 的网址留在这个 pefile 里面吧，所以你的 pefile 里面去扫一扫，一定会有一些字串是跟网址长得像，对不对？ So there are some URLs, contact URLs. So you can see there are a lot of URLs. So maybe you can extract them from your pfiles by using static analysis. Or you can set up a sandbox to do dynamic analysis and to capture all the HTTP traffic sent from the malicious file to the remote server, and you record all these URLs. 你有两种方法，第一种就是去 P 档里面去字串里面去挖没有 URL， 另外一种就是你 set up 那个 sandbox， 走 dynamic analysis 的路线，去找一个 monitor 去观测它的网络流量。看有没有连到哪些 HTTP 的这个 server， 你就把那个 URL 留下来，都可以，就是这两种手段都可以让你得到这个 URL。Okay, and also there are some contented domains, contented IP address, and you can simply just use static analysis to extract them from your pfile, or you can observe them by using dynamic analysis. So that's it. Behavior. If you do dynamic analysis, those network communication can be observed by your monitor. Those are HTTP requests, DNS resolutions, and I believe you have learned it in your network class. Then, file system action. When we do dynamic analysis, we can observe what files has been touched by the malware. So here's the list. Okay, we can see that this list open a lot of Windows system file. For example, WinIME32, that is for IME 就是个输入法 okay, IME is the imputation method, and so on and so forth. There are a lot of files has been touched by this malicious software. As you can see that there is a very strange file has been created or touched or opened by this malicious file, which is under drive C, okay, document and setting administrator local setting temp, and there is a file called 996e.exe. And we strongly believe that this file is a replication of itself, and the malicious file put this replication in this specific temporary directory. 我们很有理由相信这个档案呢，这个99161.exe通常我们用猜的就猜出来，它是这个恶意程式的自身的一个复制档。因为有时候他想把自己藏在一些莫名其妙的地方，你放在桌面上不可行嘛，你身为一个 user， 你很常就会看到它， 所以它通常会找一些它可以 access 的目录，因为你看这是一个 temp 的目录 ，temp 的目录大部分的人都可以 access， 因为它是暂存目录嘛，他会把自己换一个名字叫996，然后把它塞在这个暂存目录里面，以后要再发作啊，或是要再复制啊，它可能就很靠这个。那其他的东西呢？其他 DLL 就不一定了哈，有些是拿过来用哈，有些是偷偷篡改那个 DLL 都有可能啦。看他做一些非常 malicious 的事情，他什么事情都做哈。And this one, okay, is very strange one. Driver C, okay, auto exet 点 .bat. This file will be executed every time when you reboot your Windows system. 中文就是说，这个档案很特殊哦，就是说写在这个档案里面的指令呢，会每一次在你重开机的时候都被执行过，所以非常有可能就是说这个档案里面写了刚刚那个 temp 里面的那个档案，也就是说你每一次重开机的时候，因为 auto exec 点 bat 都会被系统过一遍，所以里面它就指向刚刚那个 temp 的那个档案嘛，所以那个藏在 temp 下面的档案就每一次开机被执行一遍，所以你每一次重开机的时候，你的电脑就是在那个被感染的情况之下，所以重开机也没有用，就是这个病毒还是一直会每一次被执行。So in this way, every time when you reboot your computer, okay, the instruction, the command written in this BAT file will be executed, and most likely the file which in the temporary directory will be executed every time when you reboot. So every time when you reboot, your file is under infection. Registry action, that means this malicious file, it tries to modify or try to access your configuration of your Windows system. 中文是说这个档案呢，它会就是这个恶意程式，它会尝试的碰触或者是修改你 Windows 的设定值，因为 Windows registry 就是放 Windows 设定值的地方。So there are a lot of registry, okay, configurations, settings will be modified or be accessed or be changed by these malicious files. Although we don't know why this malicious file would like to access such amount of Windows registry. It even create new registry or delete some registry. So let's go back to our code. So after we know there are a lot of variable information can be extracted from PE files, there is a very useful Python package called pefile. So you can simply just install this package in your Colab, which is okay. So you simply just use this command to install pefile package in your Colab. So after that, you import this file. So that is the file we'd like to analyze. You simply just call a very simple function, pefile.PE. It will try to analyze the file you provided, which is pe32.exe. Fast load means we would like to do a complete analysis. So you can set it to false. This object is an analyzed PE file. There are a lot of different functions can be called. For example, is this file a DLL file? No, it's not, because it is an exe file. Is this file is a driver, which means is it Windows hardware driver or software driver? No, it is not. Or is it an exe file? And yes, it is an exe file. How does this package, pefile package, know it is an exe file? The code is exactly the same as I show you. How do we know it is a PE file? We have to read the first 2 bits of this file to make sure it's a DOS file. And then there is a pointer pointing to another 4 byte. And this 4 byte should be written as capital P, capital E, 0 and 0. And then we know it is a PE file. So basically, you should follow the structure of PE file to make sure it is truly a PE file, not a file with .exe file extensions. 这个 exe 这个它的里面的 code 你去看，它也是按照这个流程去知道说，你要先读前面几个 byte 是确定它是 DOS file， 然后找到 pointer， 然后 pointer 再找到那4个 byte， 那4 byte 里面一定要写 PE 斜线0斜线0，它才会确认它是 PE file， 然后它是 exe file。你不能够说它的副档名是 exe， 它就是 exe 这没有这回事。So that is an object, right? PEF is an object. So there are some attributes you can print them out. For example, file header dot machine. So 332. Why is 332? So make sure you go back to the table. 332 is right here, right? So that is a 32-bit x86 architecture. 所以就查表了。So that is more convenient for you to print those values. So you don't have to parse those files by yourself. Pefile package has already done the things for you. So you simply just, for example, print file header timestamp, and that is the time that this file has been compiled. There's another hash function. We can get the hash function. Of course, you can print its MD5 value, SHA-1 value, SHA-256 value. And then the next one is section. As we mentioned before, there are different sections which include different information in the section. I'm afraid you have to take a look at this code by yourself, okay? So that means I would like to print. There are 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 sections included in this PE file, and I can use the above code to print this file. And the name of this section is written here. It's very similar to the example which I show you in the ViceTotal, right? The name is .text, which include all the machine code of this sample. TST 这个 section 里面放就是你 compile 完那些 code 了啊。然后一样嘛哈 ，R data， 那RS、RC、reload 这些都是常见的名字。Of course, there are some very specific section. Okay, 00 config, GFIDS. For every different compiler, they have their own rules to name this section. So basically, you can name section using any strings. So basically, there are 7 sections. And of course, here are some information right here, right? Those information are exactly the same as I show you in the ViceTotal, okay? Including how many bytes in this section. For example, this one is 577024 bytes in this section. So that is how many bytes. And that is entropy, which I will describe later. And that is the hash value of this section. So basically, you can use PE package to parse the PE file and output those things. And this can be variable when you do your model. So I will talk about entropy later, right? Entropy first. Okay, entropy later. So keep it in mind. Okay. The next thing I would like to mention is packing. Malware sometimes pack itself with some packing tools because it can change its appearance for not being detected by antivirus engine. Okay, what does that package mean? If you have a file and you compress it by using zip, and you can get another file which is appearance. Appearance means everybody, but if you know how to uncompress, which means how to unzip this file, you can obtain the original file, right? 如果你有个档案哈。然后呢，它有一个原本的样子嘛，所谓的样子就是它每一个 byte 哪一个 bit 的样子。那然后如果你去对它做压缩啊，你压缩完之后会得到另外一个档案。你那另外一个档案里面的每一个 byte 是不是都跟原本 byte 不一样，对不对？因为它有一个演算法可以压缩。可是你可以经由解压缩把它还原成原本的样子。也就是说，你可以经过一个程序，让原本 file 的样子变成完全的另外一个样子。那么你就成功的做了一次 packing。packing 有很多技巧，压缩、解压缩是其中一种，加密、解密是其中一种，还有各式各样不同的 packing 的技术。packing 的技术的重点是它要让原本的样貌，就是每个 byte 的样子变成另外一个样子。因为很多 antivirus 的引擎这边有写哈，很多 antivirus 的引擎他们就是根据你的样，也就是所谓的每个 bit 的 byte 来做 malicious software 的 detection。所以一旦你的样貌变了，你压缩过一遍了，加密过一遍了，你的 byte 的样貌就变了嘛。So there are a lot of different packing techniques. For example, you can do compress, uncompress, encryption, decryption, and so on and so forth. As long as the files after compression, after encryption, the appearance, which means the byte, is totally different, then antivirus engine may not detect this malicious software. So a lot of malicious software will do packing before the hacker release its malicious. 所以在很多时候，那个骇客在释出他的这个恶意程式的时候，到网络上的时候，他们都会做一次的 packing 啊。那下一个版本啊，再做另外一个 packing， 就是不断的做各种不同的 packing， 所以它每一次的样貌都会变。那这样防毒软体公司就很难去抓到一个固定的 pattern， 因为压缩、解压缩、加密、解密出来的东西都很乱。So here's a famous packer called UPX. Okay, you can check it out in the website or Wikipedia. So let's take a look. You can install UPX package in your Colab as well. After that, we make a copy of our original T10-3 exe file, and then we pack the copied file. We have a ultimate packer for executables. The current version is 3.94. We have an original file right here, and after pack it is right here. the compression ratio is right here. The original format is Windows PE files, and after that is packed. Again, we can see that is the original one, and that is the packed. And we can see that the file size is a little bit different. So let's see. If we all take a look at this packed file by using the PE package, it says, okay, after pack, it is still a PE file. After pack, it is still a 32-bit x68. But after pack, as we mentioned before, since the size is different, the pack bytes are different. So this MD5 hash value is 4C6B, right? Which is different from the original one. And if we use this pack file to do signature verification, and it says it has no signature, right? Because this file has been packed, okay? If I have a lot of malicious file, how do I know this file has been packed? So 就中文上来说，就是你知道兵来将挡，水来土掩嘛，对不对？所以坏人会知道每一次 release 他的东西之前要先包过啊，因为包过的内容就会变嘛，反正他可以再解。就好人这边来说，那我们就要知道一个档案过来之后给你分析的时候，它是有被 pack 过的，还是没有被 pack 过的。There's another tool. If you install PE files, there's another package called PE Utilities, PEUTILS, and then you can download a reference file. So you can use this reference file and feed them into your program, okay? And it says that you use PE Utilities, and there's a signature database, and you include your reference file, and you can ask the PE utility if this file has been packed or not. And for this file, that is putty32.exe, right? And it says no, this file is not packed. However, for this file, putty32 packed file, and it says yes, this file has been packed, and maybe it is packed by UPX. So you can download a reference file from the internet, and you can use PE utility, and you feed the reference file to PE utilities, and the PE utilities can help you to identify if the PE file is packed or not section. So we can see that the original putty file has 7 sections, right? And then after packing, the UPX tool only contains 3 sections. Of course, those 3 sections include all the original 7 sections. So it has different, for example, file size, different entropy, and different hash values, right? 就是说我们原本的档案不是 putty32嘛，然后里面有7个 section， 对不对？然后那个 packing 其实就是很妙，它就是把原本的东西啊，想办法把它包装起来，然后产生一个新的 PE 格式。那 PE 格式里面只有3个 section。那想办法把原本的7个 section 还有它自己的演算法哈，想办法把它包装啊，然后把它塞在那个3个 section 里面，可以吗？这是 pack。那 unpack 的时候，它会想办法再把这3个 section 里面的东西挖出来，然后想办法再把它还原成原本那个7个 section。以范例来说是这样。That is section and packing. And usually malicious hackers will do packing before they distribute their malicious software. Again, we'll talk about entropy later, okay? So here is another section, it's called libraries. We can output how many libraries has been used by this malicious software. Okay, you have to take a look at this code by yourself, okay? So I print putty32. They use several different libraries right here. And those libraries provide the following functions. 这边就会你反正看上面的 code 嘛，好，这个范例是我写的哈，那你就可以知道我下面会印出来，就是说这个 putty32啊，它用了哪些 Windows 的libraries， 就前面的上面的这个名字点第2档啊，那些 libraries 提供 putty32哪一些的 functions， 所以 putty 就是用这些 functions 就好。那同样的哈，你可以想一下，好人在写一般的，因为 putty 是一个 SSH 的程式嘛，对不对？所以它里面应该就是有些 SSH 的东西啊，网络交换讯息啊，或者是做那个视窗界面出来那些东西哈，就是有下面这些 functions， 那你就要想。这些方选组成到底跟一般的坏人在写那个坏程式的时候，他们是不是也会用这些 functions? So I have to think about it. That is putty32 use those functions to create its application. Okay, it has a GUI. You can input a lot of command. You can SSH. You can telnet to other remote servers. So they use these functions to create such kind of program. But however, does malicious programs, hackers, they use such kind of functions or they do not. If they are different, normal users use these functions and hackers do not use these functions, then you can use these functions as features to create your classifier. So next is string analysis. I believe you know what is ASCII. There are 256 different characters in ASCII, but not all of them are printable. 就是 ASCII table 里面有256个不同的 character， 但是不是每个都可以在荧幕上印出来，只有下面这一些我印出来的这些可以被印出来。Only those characters can be printed. It's right here. So if we would like to analyze the string content in the pefile, then we can do this. I would like to print out the consecutive characters which are all printable. 好，中文再讲一遍。我想要创造一个function，这个function可以吃 pefile， 然后里面要印出什么呢 ？consecutive 就是连续的嘛 ，characters 连续的字元，而那些字元全部都是 printable 的。好，比如说我们要去连一个 URL 里面字一定就全部都是 printable 嘛，对不对？或是我要印一个字串在我的视窗里面，或是我视窗上面有标题，或者是说我的 putty 里面就有一些 configuration 的，起码 button 上要有字嘛，对不对？那些东西应该都是 printable， 所以我们可以尝试把这个 pefile 里面所有连续可列印的字元全部都印出来。I write the function right here. Here, I would like to print all of the consecutive printable characters. So as you can see, the first consecutive printable characters is this program cannot be run in DOS mode. This string exactly in the very first field in the DOS headers. 就这一串字啊，就真的在那个 PE 档案里面那个 DOS field， 我们讲 DOS field 是最上面嘛，对，它里面就有这些字。所以你其实就是可以无脑的把它印出来，你不用分析，你就是把连续可列印的字元把它印出来就好。And as we can see that .txe, .rdat, those texts are exactly the name of the sections. 就是刚好 section 的名字啊，它也是连续可列印的字元嘛，所以你就可以把它印出来。All of them are sections name. 就是很巧合的，因为我们讲嘛，后面的东西都基本上应该就是比较 binary， 然后一些图片啊，一些这个 compile 好的这个 machine code 啊，他们就是恰好也可能有连续的字元，在 compile 完之后刚好是可列印的，就会像下面这样。I mean, accidentally, your compile code, the image contained in your pefile, they accidentally has some few bytes which are printable, but actually they are binary values, but because we do not distinguish them, so they will be printed as follows. Okay, there's indeed some strings which is very important for the malicious software. For example, IP address, the URL to connect it to the remote server. For example, some ransomware will put the Bitcoin address. They are all printable characters. Those information, those strings will be printed right here. 这些算是有可能有些资料是有用的，有些可能资料是没有用的，有些字串，那就看你怎么样把它放到你的模型。Next will be byte secrets. If I do not want to analyze the structure of pefile, I would like to analyze the pefile 1 byte by 1 byte. 就是如果我很懒惰，我不想要分析 pefile 的结构因为 pefile 的结构太麻烦了，那么多栏位，然后每个栏位有不同的意思，对不对？那如果我真的想要一个一个 byte 去分析 pefile， 可不可以呢？可以，你就一个 byte 拿出来。So I write the function right here. We count the pefile 1 byte by 1 byte. However, as we know, 1 byte equals to a bit, right? Then a bit is from 0 to 255 if you view it as an integer. So we can count how many bytes in these pfiles belongs to 0. Or belongs to 255， 就是说我们把 pfile 我不想分析了，懒惰嘛，我就一个把它打开。那一个打开之后，我就一个 byte 一个 byte 数。那一个 byte 就8 bit 嘛，8 bit 不就是0到25嘛？所以我们就去数啊，这个 byte 如果算出来的整数字刚好是100，我就在100那边加1。我就一个一个数，我就数这个0跟255这256个不同的值啊，一个一个 byte 到底在这个 pfile 里面占的distribution 长什么样子，我就画下面的图。So we can draw this distribution by using this function. And as you can see that 00 has a lot of count within this pfile. 就这个 pfile 里面的结构啊，如果你不论结构的话。 你就单独的数，你会发现00这个 byte 出现数量特别，还有这个 this one is FF。These two values, the majority 就是多数了of when you count the pefile in this way。那为什么00很多？因为 pefile 它有一定的结构嘛，对不对？所以那它有一定的长度，所以有很多时候那个长度不到的时候，它会填那个0进去，就是塞满那个结构不够的部分啊，或者有些数字嘛，比如说你有个整数好了，你的整数是那我们知道写 Java 或者写 C 啊，写 Python， 它们整数大概都32位或64位，可是有时候整数我们写里面的只是1嘛，那前面不就是0000一堆31个0，然后再接一个1吗？对不对？就是很多数字啊，或者填充的 padding 里面都带很多的零，所以这个 P 档里面就很多的零。P file is structured, so sometimes we have to pad a lot of zeros or FF, which means all ones, to do the padding of the P file. So 00 and FF are extremely large. However, if we take a look at pack file, and we can see that after packing, this file, the byte distribution of the packet file is quite even, right? Through this part. Of course, 00 and FF still majority. However, all the other bytes from 1 to 254, they are quite even. Unlike a normal PE file, they are not that even. 就是在我们发现在 pack 过程，因为你知道我们刚刚不是讲嘛 ，pack 会应用的技术有哪一些啊？不外乎就是什么加解密啦，还有这个加压缩解压缩嘛。那你知道压缩解压缩跟加解密啊，他们都数学家发明的嘛，对不对？就把原本的 byte 想办法做一些运算，变成另外的 byte。压缩、解压缩还有加密解密，它们都有一个特性，就是它们会尽量没有办法让，应该说它会 evenly distribute 它的产出。你看嘛，一个字被加密过之后，它应该要均匀的散布在00这个 byte 到2到 FF 这个 byte 之间，这样才不会被人猜出来要怎么样解密。所以 hash 啊、加密啊、压缩啊，他们都有一些数学理论，他们都会均匀的让原本的 byte 散布在新的 byte 上，所以就会产生这个效果。Compression, decompression, encryption, decryption, the mathematics behind them are hashes or some encryption decryption algorithms. Those mechanisms will evenly distribute the original byte to another space, which is the below one, will evenly distribute the byte so that you cannot do decryption without key. Okay, those are mathematical features. 就它们有一些这个数学的特性。So even if you do not have PE utility, you can simply just count the byte distribution of your P file to know if this file is packed or not packed. 所以即使你没有我们刚刚讲那个 PE utility 那个工具啊，没有那个 reference file 啊，你可以单纯的就借由 count 这个 byte 的 distribution。如果你看到它这么平均，它一定加密过，一定压缩过，一定 pack。如果你看到答案比较像上面那个样子，那就是一个一般的 P 档，因为一般的 P 档里面00很多 ，FF 很多，然后中间的东西，因为中间都是 code 的用字有一定的 distribution， 所以它会有一点不平均。So that the next one is assembly. So basically, because our code in the TEXT text section, they are compiled machine code, right? So basically, you can the assembly package can help us to decompile, which means deassembly those code. 所以这边就是说，我们可以因为里面有很多 machine code 嘛，所以我们可以对它做 deassembly， 就是把它还原成 assembly 的样子，就把它印出来。Okay. Some researchers believe that the assembly code like this, we can tell the difference between a malicious assembly and a benign assembly. So maybe that is a very useful information for you to do some research about assembly code and to distinguish malicious assembly. 我觉得有些研究者认为说，你把那些 code 做完这个 disassembly 之后呢，你有些人可以看得出来，但我们可能比较不行的哈，因为这个经验比较少。有些人可以看出来，他这样写就是坏人的写法啊，另外那样写就是好人的写法啊。如果你真的可以辨认出来这件事情的话，那你就应该把 disassembly 之后的结果放到你的 model 里面去，作为其中一个 feature， 然后去做你 class. Okay, let's take the next one. Okay.Sometimes we have another hash called fuzzy hash. So you can simply just input your P file into such kind of hash. This hash has a very specific feature, which is if your input byte is similar, then after you input those files into fuzzy hash, the hash result will be similar as well if your input byte are similar. So you can try this function as well. Okay, that is the fuzzy hash 的意思就是说，我们的 hash 都是说你要产出一个独特的 hash 值嘛，对不对？但是 fuzzy hash 不是哦 ，fuzzy hash 是如果你的 code 你的 byte 原本是相近的，你有2个档案，它们里面的内容 assembly 啊 P 的内容是相近的，那它丢进去 fuzzy hash 之后，它出来的 hash 值也会是相近，所以我们就可以用这个方式来测量2个档案有多相似，可以吗？那详细的我们就不讲，因为这个比较少用啊。那也就是说，如果有一个骇客，他今天写了一支坏程式，然后做好打包丢到外面去，那他明天呢想了想，有个地方可以修改一下，所以他就修改了他的 code， 再重新 compile， 再重新打包，再重新丢出去。那现在有2只嘛，对不对？可是2只都是来源都是差不多的，对不对？所以你要做的事情就是 unpack， 那你就得到2个 unpack 的东西。然后你把这2个东西拿去做相似度的比较，那当然相似度比较有很多种，我们以后还会讲很多不同。那其中一种是这个 fuzzy hash。如果你发现它的 fuzzy hash 也很相似，那就表示这2个 unpack 过的 PE 档案，它原生也很相似，所以我们就几乎能够判定说，这2个 unpack 的档案应该是来自于同一个骇客的手笔，因为他们2个的差异少，所以这2个应该就是比如说兄弟姐妹的关系啊，或是同家族的啊，或是同一个骇客输出的啊，或者说他们做相似的功能。这些东西就给大家做参考。那 static analysis 能够做的事情就大概就是这一些。Okay, so that is the technique that we can apply to do static analysis, including to parse its pefile headers to extract the useful information from those headers. Second, to understand what are the sections used by this pefile. Third, what library that invoked by those pfiles. Fourth, what strings are contained in these pfiles. Next, what is the byte distribution of these pfiles? So those are very useful information for us. So we will use this information as an example to do a classifier. So let's stop right here.